Hey folks, Quill18 here, and welcome to another episode of Let's Play. Wait, sorry, I'm getting confused about my two channels. Welcome to another Unity 3D tutorial on how to make a multiplayer first-person shooter. So, last time I promised we would start actually doing the shooting place. We've got the multiplayer part of it, we've got the first-person part of it, we just don't have the shooting part of it, so we're going to do that now. First, a little bit of theory over here in Paint, because God knows my painting is so awesome and unbelievable that, we want to do more of that. So, what is the theory that we're going to go on here? First of all, what we're going to do is we're going to create a box. That's going to be our first target, just because that way we can just play in single player mode and have a box to shoot at. So, we're going to have our dude guy over here, and we want to be able to shoot the box. Now, what does it mean to shoot something in a first person shooter? Well, you are shooting directly out of the middle of your camera. In your screen, the middle point of your screen, you can even put a little crosshair there, that is what we're shooting out of, and whatever's right under the middle point of your monitor, that's what gets shot. Well, think back to our character over here. He's got a camera in his head, right? So the camera, it's got a sort of center point here, and then the way it's actually represented in the game world is it's got this sort of volume that kind of comes out like this. And the near bit here, this flat bit here, and I mean, even though my lines don't actually work out. There we go. Hold on. Let me undo a few steps. So we've got our camera here. It's facing forward, and it sort of does, you know, something like that. Like, that's your eye. In the game world, it's actually represented as having this sort of short face here. That's your near clipping plane. Anything closer than this won't get rendered on screen at all. But that's what the camera looks like. So when we are shooting in the middle of the screen, what we're actually doing is whatever direction the camera is facing, we are going to be shooting basically an invisible ray directly forward from the middle of the camera. We're going to shoot it forward and see what that ray hits. And that includes, if we're looking upwards, then the sort of camera cone is going to be more like that. Right? And then the near clipping plane was the same thing. We are shooting a ray directly from the origin of our camera, which is over here, and directly forward from the camera's point of view, based on the camera's local rotation. We are shooting a ray forward out of that. And then again, we're just trying to figure out what we have hit at that point. To start off with, it's just going to be a box. That way I can just do this in offline mode. It'll actually keep things going a little bit faster. All right, enough theory. Let's go back into Unity. Now, first thing I'm going to do, in my scripts global object over here, I have my network manager. Let's go ahead and click on that. Open that up in MonoDevelop. And we're going to enable an offline mode. And it's very simple. What I'm going to do is create a Boolean. In fact, I'll do a public bool offline mode. It can default to false. Now, in Connect, we're going to do an if here. If offline mode is true, so just if offline mode, do something else, which is if we're not in offline mode, do the normal connect. The way, if you go into offline mode, the way you cancel offline mode is actually to do this connect using settings, so we definitely don't want to run this. This is the line that actually connects us to the server. So if offline mode, we want to tell the Photon network, we are going offline. And by telling it that we're going into offline mode, which we simply do by setting true right here, what it means is that it will allow all other Photon networking calls, RPC calls, the Photon views that synchronize stuff over the network, all of our networking functions will still work. We can call those. That means we don't have to do a whole bunch of ifs throughout our program. We don't have to check to see everywhere if we're in offline mode or not. It doesn't matter. We just assume we're online. We do the calls to the Photon network as if we were online. And the only thing is that if we're not online, in other words, if offline mode is true, then it simply doesn't send anything over the network. What we have to do is skip this step here, which is connect using whatever. We just have to skip the connect call, but everything will work fine. So what we want to do is set offline mode to be true, and then just pretend that we have successfully connected, which is what happens when onJoin lobby works. Because normally you connect, and then what happens is it automatically calls this function, which is onJoin lobby. So we're just skipping the connect phase. We're setting offline mode is true, calling onJoin lobby, and then everything should work fine, except when I hit play, it should actually be instant. Oh, wait, except I actually have to toggle on my little Boolean here for offline mode right over here. If you don't do this, then you're still going to be connecting to the actual server. So if I hit play, it should insta-connect, And other than that, everything should work totally fine. We should have no weird errors in our console, just the regular logs. And that's great. Except, obviously, if I start a second copy of this, then they won't see each other because they'll both be in offline mode, right? So if I went File and then Build and Run and got my Windows version of things running again, they would be connected to their own offline instance of things. So this just means I can connect slightly faster and drives me a little bit less bonkers. Okay, so with that in mind, the other thing I'm going to do is my invisible map stuff folder, all these spawn spots, I'm actually just going to get rid of them all. Well, all but one. Because, again, to save time and frustration, I want to know exactly where I'm spawning every single time. So I've got one spawn spot. It's right over here, so that's where I'm going to pop in. And that's good. So if I hit play, I will be guaranteed to spawn right there. Good. Exactly what I want. Then I'm going to put a box in front of me to shoot. Okay, so, whoops, what did I do? I selected all. That's not what I meant to do at all. All right, I went to do Control-S to save. So our box, we are going to follow the same guidelines that I keep telling you guys is the best way to do things. We are first going to create an empty, which is right here. I'm going to position it to be roughly in front of where my dude will be, which will be there, and then we'll put it sort of closer to the ground. In fact, I'm going to put it at 0 point. Right? And then I'm going to put a box there. One can imagine the code that I'm going to make for this box actually would work great as a explosive barrel, anything like that. In this case, I guess it's going to be a crate that we're going to blow up. In fact, I'm going to rename the game object to crate. Now, the crate needs a graphic, at which point I could go into my 3D program. I could go into Blender and design myself a nice crate. Instead, I'm just going to go to game object, create other. I'm going to choose one of the normal cubes. Now, again, I am not just going to use a cube as my base object. The cube is actually, these are just my graphics. That's all it is, just my graphics, okay, that I'm using here. Now, the other thing the cube is going to provide is the collision mesh going on here. Now, it doesn't have to be here. In fact, what I should do, first of all, is zero out all the coordinates, except for the Y, which I'll move up by half a unit. There we go. So now it'll be nice and touching. So the advantage of this is my crate is at the 0 point, so it's sitting flat on the ground, and that's exactly what it looks like, even though I've had to offset the graphics. The big question mark is really where this box collider should be. Because it doesn't have to be on my graphics layer, right? It doesn't have to be part of my model. I could remove this. I will need a collider because I need to, kind of shoot things, right? It doesn't have to be on my graphics. I could go to my crate level and add a box collider here, and then just position it where it should be. And that's fine. And the advantage of this is I can swap out the actual graphics. And in this case, I could just turn off the graphics. But my collider is still there. So I can change my graphics object in and out, and it doesn't change anything about what my collision should do. And that works fine if you're using a box collider or a sphere collider. Where's my components? Right, physics. Box collider, sphere collider, capsule collider. Those three will work great on just your base level, just like this box collider does. The problem is if you've got a more complex mesh, right? If you've imported an object, for example, our level here, right? We have our level, and it has a mesh collider on it. If I go to the ground level, it's got a mesh collider, because we can't just use a big box for this. We obviously want to use a collider that matches the mesh perfectly. So if our object here is supposed to have a proper mesh that is fitting exactly, I don't know, it's a statue or something like that, then in that case, having the box collider on the base object really is A, inconvenient, and B, doesn't make any sense, because if you change the graphics, you kind of want to change what the mesh collider is going to look like, because if you change the statue, you'd make the mermaid twice as big or something like that. Well, you want the mesh collider to follow that exactly. So what we're going to do, even though this keeps things much simpler, by having the collider on the base layer, life is so much simpler. And we're going to see why that is. Well, I suppose I can explain it a little bit. When we shoot out our ray from my gorgeous Photoshop picture here, or paint photo here, when we shoot out our ray, what the ray hits is a collider. There are ways to do it with the graphics and things, but that would be silly. We want to shoot and hit a physics collider. And what's nice about when you have your collider on the actual base object, like this crate here, then the object gets returned. You hit the ray, and you ask the ray, hey, what object did you hit? It will return crate. Instead, if we have our collider on graphics, which is actually what I'm going to be putting back here to simulate the I'm going to take off the box collider from the base layer, And I'm going to put it back on the graphics layer. And yeah, everything is aligned properly. Here what will happen is if I shoot out this ray and hit this, the ray is going to tell me I hit graphics. And the problem with that is, generally speaking, you're going to have most of your scripts on the base layer. So that's okay. This is actually the way we're going to do it, because what it means is we'll actually keep that in mind and design some nice functions that properly deal with this problem. Now, first thing we're going to have to do is create a new script for this crate. We're going to have to give this crate sort of hit points. Basically, anything that can be blowed up is going to have this, I'm going to just literally call it health. Okay, it's going to have this script on it called health. This thing has hit points. It can take damage and it can die. That's what this represents. So you can shoot anything. I mean, you can shoot the ground, but nothing will happen. I mean, maybe, you'll do a little ricochet effect, a little smoke effect, a little whatever. I mean, obviously, if you're shooting a rocket, then the rocket will explode when it hits the ground, that sort of thing. But the ground will not actually be affected. The ground don't care. You might put a decal there to show like a chip mark or a smoke mark or something like that, but the actual ground object doesn't care in any way whatsoever. But this crate, we can blow up this crate. So it has health. And obviously the players would also have health, but because I'm working this offline mode, I don't need to have, 2 players connected. It'll be far more convenient to start this way. So let's open up the health object. And we're going to create a very basic and also wrong implementation. I know I do this a lot in my videos, where the first pass of it is actually going to be vaguely incorrect in some way. And we'll see why that is. So we are going to have, this object will have hit points. We'll use a float for this, just so that, we can do rounding. If there's percentages, it'll work. But, depending on what game you make, you might be fine with an integer. Usually you only want to display an integer. You want to show that something is at, 53 health remaining. You don't want to show 53.137 or something crazy like that, but it's actually not a bad idea to keep track of that. So we're going to call this hit points, and we're going to have it default to 100. And you don't actually have to put the F there for floating point, but I like to do it as a habit. And we're going to make this a public. Okay? So then any object that's got health will have a number that we can tweak. Now, 100 hit points as a base seems reasonable for players. I mean, you can pick anything you want. You can give players 1,000,000 hit points and then just make your weapons do 10,000 times more damage. But, a nice 100 seems good. Now, we don't want our crate to be as tough as a player, so on this crate, I'm going to change this crate's number to 10. So that seems good. Maybe we've got some wimpy, crappy weapons that might not blow it up in one hit, but generally speaking, it's probably going to die for one direct hit, and that to me seems pretty reasonable for a crate. All right, so hit points, does it represent maximum hit points or current hit points? You could go either way. You could actually call this max hit points. What I like to do is then create a not public current hit points. And then in the start, I will set current hit points to be equal to hit points, which is actually the maximum. And you know what? That's good. We don't need an update function at all. What we do need is we need a function called something like take damage. And it'll take a certain amount of damage, and all it does is our current hit points will be reduced by the amount. Right? Fair. Okay. And then maybe something like if current hit points is less than or equal to 0, then die. We'll call another function called, oops, it was auto-completing because I don't actually have the function yet. And we'll say, okay, function, it doesn't return anything, it just die. And all we're going to do is destroy ourselves when this comes up. All right, fine. We're going to just destroy the current game object. Actually, I guess you go game object.destroy. No, I had it right. Destroy our current game object. There we go. Easy. Take damage will actually have to be a public because we're going to be calling it from another script. This is not correctly programmed for the networking, but we'll deal with that later. This should work perfectly fine in sort of offline-y kind of mode. Okay, good. Now all we have to do is design something that will call take damage. So for that, we need to go back to our player, who is currently, actually what I should do is under levels, we've got prefabs. Let's go and make this crate a prefab, but we're going to leave this one in the game world, and that's good. So in our player, we want to give our player the ability to shoot, and the player is going to work very, very similarly to the something like the player movement script. In fact, this script could potentially handle the shooting as well, especially if, we renamed it. Instead of being called player movement, we call this player input or player control or something like that. But, you know, for the sake of keeping each script as simple as possible, I'm going to create a new script here. I'm going to call it, what's it called? Player movement. So we're going to call this player shooting. That seems good to me. And we're going to do the same thing in that it'll start disabled, right? Because this player shooting script is going to respond to mouse clicks, right? Because your left mouse button, that's your fire button. Well, actually, we're not going to map it to left mouse click directly, but we have an input set up called fire 1, which is mapped to left control and mouse 0, which is the left mouse button. So that sounds good to me. Seems like a reasonable way to shoot, but we want to make sure, just like player movement, we want to make sure that all the other players in the game, when you click your left mouse button, you don't want every player object in the game to fire simultaneously. You only want your player to fire. So we start with it disabled, and then over in our network manager script, when we spawn our player, spawn my player over here, when we have our player movement script enabled, we're going to also do player, what do I call it? Player shooting. Tell me I called it player shooting. Where's my resources? Player shooting. Yeah, there we go. So we're also going to want to enable player shooting just for us. Again, you could flip this around kind of the other way in that you start with everything enabled except and then you have to disable them when a player spawns in, but it would actually be considerably more awkward to do. It's way easier to just make this all disabled. Everything that relies on actual, like, stuff I'm doing on my end. Disable it all. And in fact, I'm trying to think. I think character controller could actually be disabled. Oh no, the character controller includes the collision box. Never mind. Yeah, we'll leave it as it. But anything that deals with input, you turn them off so that everyone else in the game does not respond to your input, and then you explicitly turn it on for yourself. All right, that should work great. So we've got the shooting script. How does it going to work? Well, it's going to have a couple of little steps. We actually don't need a start or an update necessarily for this. Oh, that's not true. We're going to do an update. Because, just like, where's my player movement script? Right? In our update is actually where we're going to listen for keyboard inputs. Well, in this case, keyboard and mouse input. So in update, we're going to do something like if input dot get button, again, do we use get button or get button down? Depends on what you want. Get button down will only trigger on the frame at which you click the button. So you can imagine if you're using not an automatic weapon, right? If you're using a single fire weapon, you might want to use get button down to simulate that, in that you have to click and then release. Click and release. So then you're shooting bang, bang, bang. Whereas with get button, this returns true as long as the button is held down. And that makes a sense for anything that will fire again automatically. Clearly it makes lots of sense for a machine gun, right? You just hold the button down and it goes. But even for weapons that aren't supposed to be quite that automatic, including something like really slow like a sniper rifle, it's actually entirely reasonable to just use get button, in that you can click once and then hold it down, it goes bang, and you keep holding it down while your guy does the reload animation or something like that, and you're still holding it down, and then when your cooldown and reload animation, all that comes up, it just goes bang and fires again. To me, this is probably totally reasonable, but depending on what you're doing, you may want to do one or the other, and literally you might want to have a big if statement based on the type of weapon it is to choose whether you use get button or get button down, right? You can do both those. I will use get button. So get button, it's called fire 1. We just checked. The button is called get fire 1. So if this is true, okay, player wants to shoot, so shoot. So I'm going to make a function called fire. Right? Void fire. So we're going to fire our weapon if we do that. And all we're going to do from input is we're just going to call fire if we're holding it down. Now, update obviously runs every single frame, and that's even every single visual frame. So if you've got a good computer, and assuming our game is not graphically intense, and clearly it's not, this could run hundreds of times per second. Obviously, we don't actually want to shoot a bullet hundreds of times per second. So what we want is we want a cooldown on our gun. So let's make a gun that fires, I don't know, twice a second. So it'll fire once every half second. So our gun has a cooldown of 0.5. Right? Sure, we'll just set that up as some reasonably fast firing sort of pistol kind of something or other, just for a particular demonstration. And then what we're going to do is we're going to have something called cooldown remaining, which will start at 0. So the cooldown, this actually represents, like, you know, the cooldown required between shots. And this is the current. Actually, you know what we'll do? We'll call this fire rate. There, that makes more sense. So this fires every half second. And then we'll just have this variable called cooldown. I think that might work out. Oops, cooldown. I think that might read better for most people. So in our fire, we're going to say something like, if cooldown is greater than 0, if our weapon is still cooling down from the last shot, then we're just going to return. We're actually going to refuse to fire. Now, obviously, this cooldown has to go down. So in our update, every frame, we're going to decrease cooldown based on the amount of time that has gone by. Right? And I could wrap this in an if. If cooldown is larger than 0, then subtract it. But who cares? Who cares if it goes into, you know, negative 1 trillions? It makes no difference. All we're testing, if it's greater than 0, refuse to fire the gun. And then other than that, we're going to just keep going. Okay? Now, you don't need these little curly braces. You know, you could just do that if you want to save a line. But personally, I like to do that just simply because at some point you might go and add more code over here. And then not having the braces will actually do really bizarre things. So it just stops me from making mistakes later on. And I like that. I will type 2 extra characters now to prevent mistakes later on, which seems like a great idea. Okay, so if this doesn't happen, if the cooldown is not greater than 0, then we're actually going to fire our gun. Now, after we fire our gun, we'll also have to remember to set our cooldown to be equal to the fire rate. Whoa. Fire rate. Thank you very much. Like that. So now we'll only fire every so often. And what we can do is go to debug.log. Firing our gun. Rawr. Like that. So let's see what happens if we play this. Right, let's get the console going up. And so in the game world, there we go, firing our gun. I'm just going to hold down the button. Firing our gun. It goes every half second. It declares that we are firing a gun. We're shooting our lasers. Good. Okay. So how do we actually shoot? Excellent question. I'm glad you asked. Woo! It's a bit late at night. I gotta go to bed, but I'm trying to finish this off without going too loopy. All right, so I talked about firing a ray forward. Okay, and we've done this sort of thing before. So what we're going to use is something called physics.raycast. And in fact, we're going to use Raycast All, which I'll explain why for a second. But either one we use, it requires a ray. All right? Now, the Raycast one, it returns a Boolean. True or false, we hit anything whatsoever. And usually that's not very handy. So usually you're going to use the version that you pass it the ray, which is here's where we are, here's the direction we're shooting out of, right? Which is what our picture is here. And then you're also passing it a second thing as an out variable to keep the hit info. So Raycast will return true or false, we hit anything. And the information about the thing we hit is going to be stored in this hit info variable, which is a Raycast Hit class. And it will contain a link to the thing we hit, exactly where we hit it, and so on and so forth. The reason we're going to use Raycast All, and I was tempted to show you the sort of wrong way first. Maybe I should still show you the wrong way first. All right, let's do it. So we're going to use Raycast. So we need a ray object. So we'll have a ray. We'll call it ray because we're very, original. We're going to create a new ray. And ray needs, well, you can create an empty one, but we're going to use this version. It needs the origin and then the direction of the ray. Well, the origin is actually just our camera, right? So we're going to have our main camera, which we can technically grab camera.main, and it's the position of it, camera.main.transform.position. I'm trying to think if that's actually the most correct way of doing it. Well, we'll see what happens. It also needs a direction, which is fine. We want camera.main.transform.forward. We want the forward pointing direction from the camera. And that's our ray. We're shooting a ray where our camera is, and we're shooting it in the direction where our camera is pointed. Easy peasy. And again, we need a Raycast Hit, which we will call hit info. We don't even need to initialize it. It's fine because it's going to be an out parameter. So we pass it the ray. We go out hit info, because hit info is something that's going to be filled in and returned by our function. I don't really like these outs. It feels really awkward to me. I like things that get returned, even though this works really, really well. It just, you don't see it very often, so it always feels bizarre. And then we wrap this whole thing with an if. If Raycast Hit hits something, then do something. And what we're going to do is go debug.log and say we hit plus hit info dot I guess collider.name. There's lots of things we could do a .name on, but that seems like the most appropriate thing. Okay, let's see what happens if we do this. So let's pop back over into our program here and hit play, which should clear the log except for our connection info. Indeed it does. And now I'm going to click while facing the ground. Fired our gun, we hit ground. Awesome! And I'm going to face here. We don't have a crosshair yet, which we'll actually have to add in a second. And actually, I'm realizing my my mouse cursor's not, locking, so it's a little awkward there. If I do this, hit graphics, right? This is what I was saying before. Our box collider, or any collider, our collider at all, mesh collider, box collider, sphere collider, whatever, is on our graphics object, not our crate. So we hit graphics. I hope that's big enough that you guys can see on YouTube. I realize it's quite small, but I'm not sure if you can change the font size of the console, unfortunately. But we hit graphics is what's happening. Plus, if I go straight down, yeah, see, there we go, that's what was going on. If I go straight down like this, it's saying we hit player controller clone. We actually just shot ourselves. And there's quite a range. In fact, I'm trying to find the point at which, oh, I gotta scroll it. Hit building, hit ground, hit ground, hit ground, hit ground. Player controller. Right here, we are already shooting ourselves. Now, keep in mind, we're shooting directly at the middle of our screen. We're not shooting where my mouse pointer is. We're shooting at the middle of the screen, and we're already hitting ourselves here. Well, it's because we have this capsule collider. The graphics aren't really representative of what things are. Now, there's a lot of little tricks that you can do to avoid doing that. What we can do, instead of shooting right where the camera is, we could actually add a little bit of forwardness. So start where the camera is, move slightly forward, and then start your ray from there. And then hopefully that will start the ray, outside of where our body is. But that smacks of like fiddly little silly annoying things that are going to be hard to get right. Plus then you've got the problem, and this happened to me in one of my games before, where someone can sometimes like sort of stick themselves on a corner like this and shoot, and because, and this becomes more obvious if we look at ourselves in the scene, because in that example going like this, remember I'm saying, okay, so we don't shoot from actually inside of our body, we go slightly forward and then shoot. Well, it's possible that we're actually shooting from the other side of the wall, or from inside the wall, and it'll let you shoot through walls basically and hit people who actually can't shoot you back. Very not a good way of doing it. So instead, what do we do? Well, here's the thing with Raycast. I'm actually not 100% sure how the internals of this system works, but I'm pretty sure the way Raycast works is, let's make a new image, because my images are so good. So we've got a person here, right? And what we have is we have, let's say we have our box, then we have a big wall, and then behind the wall we have another person. And I'm pretty sure that the way it works, when you shoot out the ray, what it actually does is the fast calculation for the ray is it very quickly determines everything hit by the ray. Now, if you just call Raycast, which is what we're doing, it then goes and finds out, well, what's the first thing that we actually hit? And that's what it returns in the hit info. Again, internally, I'm not 100% sure that that's how Raycast works, but that is actually how we're going to solve the problem. Because right now, what can also happen is it can say, oh, the very first thing you hit is yourself. You hit yourself in the belly. And sure, why not? So what we're going to do is instead of calling Raycast, we're going to use Raycast All. And what we're going to do is then we're going to get an array of everything we hit. We're going to find out we hit ourselves, we hit the box. In fact, it'll even tell us if we hit the box in more than one place, to be honest. It tells us we hit the wall, it tells us we hit this guy here, we hit a back wall, we hit the moon, the stars, the edge of the known universe, and so on and so forth. And then what we're going to do is loop through that set of items that we hit and find ourselves what the closest object is. Now, assuming Raycast is actually doing that internally, the performance is going to be the same. I don't know if Raycast actually does all this internally or not, so possibly this will be slightly slower, but it's okay given what's going on. The other thing you can do when you send Raycast, you can give it a distance, a maximum range, and so it'll sort of cut short at that point. And if efficiency is a problem, if you've got a big open world shooter, then you want to set a maximum range on your bullets so that you don't go and calculate things to infinity and beyond. But for our particular map, it's going to be fine. So what we're going to do is we're going to create a new function, and the function is going to be it's going to return the first thing that we hit, the closest thing that we hit that is not us, and also has health. Probably? Well, no, I was going to say that's actually all we care about right now, but technically if we're doing like, the gun smoke effect wherever we shot, we're okay with the fact that the wall doesn't have health. We're obviously not going to be applying any damage to it, but we're still going to want to do a little pachoo kind of effect, a little spark on the wall or something like that. So, okay, we're going to create a function that simply returns the closest thing that we hit. I think that's probably all we need. Well, keep saying that. Hold on. Because we actually want to know, for the special effects, we're going to want to know where we hit it. Okay. All right, so instead of returning health or anything like that, we will simply return a Raycast Hit info thing about the closest thing we hit. And that will include information about exactly where we hit it, what the collider is, and so on and so forth. Lots of good information. All right, so we can do that. Find closest hit info, and all we're going to do is pass it array. So it wants array. So over here, we're going to change our function so that hit info is equal to find closest hit info of our array. And then we're going to do stuff. In fact, what we're going to do, we can fill it out here. If hit info not equals null. If it's null, we didn't hit anything. We just shot our gun directly up into the sky and hit nothing at all. And depending on how your system, your game is set up, that might never be true because you might have a skybox. So it'll return the fact that, hey, we hit the sky. But in this case, we don't have a skybox, so it's entirely possible that our hint info returns nothing at all. Which is legal. It's okay. In which case, yeah, we just set the cooldown and then we do nothing. We don't have to do a special effect. We didn't hit anything. We shot at the sky. We obviously need no, graphic that says we hit a cloud. We'll just move on. But if we hit anything else, then we'll do something. All right? And we'll fill that gap in a little bit. So over here we have array. So what we're going to do is we're going to do a physics.raycast all, and we're going to pass it the ray. Now, physics raycast all, if we go here, you can see it returns an array of raycast hits. So we have a raycast hit array called, and we'll call it hits, like that. And then we can simply do for each raycast hit in hits. I know, that's a lot of the word hit going on. We're going to do something. Now what we want to do is we want to find the closest one. So, okay. So we've got a raycast hit called closest hit. And it can start off being equal to nothing. And we can also have a float called distance. We need to know what the distance of the closest one is. And it will need to be initialized or it'll whine at us later on. We'll just set it to 0. And that's fine. So we're going to loop through each one of these. If hit dot. Well, what's our if? First of all, we want to make sure we're not hitting ourselves. Stop hitting yourself. Stop hitting yourselves. So if hit.gameObject, if hit.transform is not equal to, and we'll make it explicit with a this.transform, just to be clear about what it's doing. Okay? Or hell, we could flip it around and say if it's equal to this transform, then just skip this loop. But we're going to say, okay, first of all, we want to make sure it's not us. So if it's not us, and what? And it's closer than our current closest hit. But our closest hit, we may not, this might be the first one, so it could be null. So if it's not us, and we're going to put another parentheses in here, and closest hit is equal to null. So either, we haven't done this loop yet. This is the first thing we've hit that is not us. Or the hit.distance is less than distance. So So either it's the very first thing we hit that is not us, or we've hit something before, but the hit distance of the hit that we're looking at now is smaller than the old distance. Then what we know is, okay, we have hit something that is A, not us, B, the first thing we hit that is not us, or, if not B, is at least closer than the previous closest thing. I know, there's a lot going on there, but I'm hoping that's clear enough. So if this is true, then closest hit is equal to hit, and distance is equal to hit.distance. There. So by the end of it, once we get to here, closest hit is now either still null, i.e. we hit nothing, or at least we hit nothing that wasn't us, or it contains the closest thing that is a valid thing to hit. Because I feel like making awkward sentences right now. So we're just going to return closest hit. And again, this might be null, but that's okay, we're checking here. Find closest hit info. If it's null, that means we hit nothing of value, so we just do nothing. But if it's not null, then we now know the closest thing we hit. So what do we want to do? Well, so first of all, we could do a special effect at the hit location, which can be something. So your hit info, you have something called hit info.point. So we could do something like, you know, do explosion effect, or not explosion, do ricochet effect at hit info.point. That's exactly where we hit with our ray. So that's where we do the spark effect or the smoke or whatever's the appropriate effect. We don't have that code in here yet, so we're not going to do that. Instead, what we want to do is find out if this is something we can damage. So what we're going to do is we're going to grab health. We're going to stuff it in a variable called h is equal to hit info dot, and anything will work. Any of these things are mono behaviors, either collider or transform or anything. We'll use transform because why not? We're going to say get component health of the object that we just hit. Actually, we should still do a debug log, right? Debug.log we hit info.transform. Oops, transform.name. All right, so we still have that debug info in there. So our hit info transform, we're going to get a component called health, and then if the health is not equal to null, then we're going to say h.take damage. It needs an amount. So what we're going to do is we're going to create a public float. Our weapon, how much damage did it do? Well, we first, just for simplicity, we know our crates have 10 hit points. We're going to say this weapon does 25 points of damage. Or that's the default. And that's what we're going to leave for this. That's fine. So we're going to say this health, take damage equal to damage. So what should happen if we turn around and we shoot our crate? First of all, we should successfully find that the crate is the closest thing we hit, which is going to go here. We're going to pick up the health object, and then we're going to tell the health object to take damage. Looking at the health object, it's going to the take damage call here. We're going to subtract 25 from the current hit points. The current hit points are actually 10 on our crate. Again, it's 100 here is the default for, you know, your average object, but we told our crate in the inspector that the crate should only have 10 hit points, which should bring its hit points to -15, which is definitely less than or equal to 0, which should call die, which should call the crate to destroy itself. This will not work. I wonder if you guys will realize why it won't work. Let's give it a quick try. Whoops. Well, first of all, there's syntax errors. Derp. Hit info can't be null. Is it not an object? It's a value type? Whoa, that's news to me. That's incredibly inconvenient. I hate when Unity does that. Just like vector 3, you can't have a null vector. And, vector 3, some vector equal null. You can't do that because the way Unity is set up, vector 3 is considered a value. It's just like you can't have an integer, some int equal to null. It has to have a number. The closest you get to null would be 0. And just like the closest you could have to a null vector would be vector 3.0. But that, to me, that's not the same. Like, the difference is between having having an integer, like having it be 0 and having it null. One is like sort of, it's not set. I did not realize that was the case with a Raycast hit. That's why before I would, so how I was debating what my return function should be here? That's why. Well, I guess that's why we do outs. So we're going to switch the return type here to a Boolean. Actually, we don't even need to be a Boolean. Well, no, we do, I suppose. That's very annoying. So it's an out Raycast hit called hit info. New Raycast. Well, actually, we don't even need set as a new, do we? So we can't check for nullness here. Oh, this is so inconvenient. I'm so incredibly annoyed at what's going on here because it's so elegant to do this sort of thing. I mean, we can just check transforms. I guess since we're not doing special effects, we'll just do it with transforms. Ugh. Alright. Let's just do this. We probably, if we were trying to expand things further on, we'd need to capture the hit info, or at least the point for the special effects at some point, but we won't worry about it for now. We'll figure out later. We'll just get it working for now, figure it out later. So, we're going to call this hit thing, or hit transform, I guess is fine. So we're going to find closest hit info is actually, like, find closest hit object is what we'll call it. It's going to return a transform. So this is going to be a transform. Return this. So this is a, oops. This is a transform. Now, Raycast hit. Yeah, so Raycast all still returns an array of Raycast hits. We're still going to sort through hits. We're still going to make sure that the hit.transform is not equal to us. If closest hit is null, that's still fine, because a transform can be a null. This is totally okay. And if hit.distance less than distance, that's great. The biggest change is here, the closest hit, we're not just setting it to a hit info. We're actually going to have to grab the transform and then return it. Everything else is still very samey. The difference is that here, we're not actually getting a hit info from this function, which means we don't have access to this dot point, which is the thing that's kind of driving me crazy. I guess if we wanted it, we could do something like, we could actually take a vector 3 called hit point, like so, and pass it here as an out, and then have an out vector 3 hit point. Hit point is equal to hit dot point. I feel like there's probably still going to be a thing here, maybe because it's not initialized. All right, I changed my function name. Let's get that matching again. Hit info does not exist in this context, right? Because it's hit transform. Hit transform dot name. Hit transform dot get component. Oh yeah, and hit point's got to be assigned at some point, so we will actually default it to equal to vector 3.0 because it's got to be something. Even though if hit transform is equal to null, that means that this hit point here has no context. It's very similar that if you did a physics.raycast and you pass it, a ray and then an out hit info. If physics.raycast returns false in that it didn't hit anything, then this hit info won't actually contain anything that makes any sense whatsoever. So, all right. So we would get the point of collision, which means we could do a special effect at the hit point if we wanted to. In this case, we're not using this information, but it is there technically. Oh, hopefully that's all the errors. So, and I believe I still said there's something that will cause this to not work properly, and we'll see why that is. We will not be able to blow up the box. If I try to shoot the ground, fire on a gun, hit ground, which is great, and then if I point at the box, we really need the center crosshairs. I'm going to take care of that in a sec. I'm going to click. It's going to say, we hit graphics, and the box did not go away. Why is that? The reason is, again, we are hitting graphics, and then here we are checking to see, hey, this thing that we just hit, does it have a health? And it doesn't. Graphics does not have health. Crate has health, but we are not hitting crate because crate does not have a box collider, right? So, what we want to do is we want a solution where the graphics layer can have the box collider, because frankly, don't think of this as a box collider, which could easily be moved to crate. Think of this as a mesh collider, which would not be convenient to move to crate. We want to leave the mesh collider on graphics, but when we do the shot, we want to check to see, hey, this thing we hit, I don't suppose it belongs to something that has a health, because if it is, that's what we want to look at. So what I'm going to do right here is I'm actually going to do a little bit of a loop. If health is equal to null, then what we want to do is this hit transform, we actually want to go up the chain, because this might have a parent, in which case in here it was. Graphics has a parent, which is crate. So let's set hit transform to be equal to the hit transform.parent. We're going to go up one level. And then we're going to check to see if this new hit transform happens to have health. And we're going to keep looping until hit transform is equal to null, I suppose. If we have a hit transform, actually, I suppose we could just check if hit transform, all right, let me just switch it around so that I can compose a more logical sentence. If the health is null, right? If we didn't get a health, and the transform has a parent. So if we didn't get health, but the transform does have a parent, let's go up the chain and then check to see if this new thing has health. And we actually don't want to do this in if, we want to do a while. While H is null, while we have not yet gotten health, but the thing we're looking at still has a parent, let's go up the chain and then check to see if that thing has health. Eventually, we will either run out of parents, or we will find a thing that has health. Whenever we finish this whole loop, if at this point we have got health, then that thing can take damage, otherwise exit. Keeping in mind, once we reach here, hit transform may not be the hit transform we started with, which may or may not be very good. Just keep that in mind, that this may have been changed. And in fact, if we shoot our crate, it will be changed, because at this point here, we are hitting graphics, but at this point here, we should now have crate is what we should have, and H should contain the crate's health. Let's try again to see if we can blow up the crate. So, center it, click. Oh, we hit ground. We're still hitting ground. Oh, there we go. I hit graphics. In my log, it says I hit graphics, but the crate went away, and that will become infinitely easier if we just have a crosshairs. So, let's go into, can we make transparent stuff in Paint? I don't even know. You know what? I actually made a crosshairs earlier, so let me go and double check on this. I have a graphic kicking around for it somewhere in my files. Assets. Yeah, there's one. So, over in Unity, in my project, so in my assets somewhere along the way, I will actually create a new folder called GUI stuff, right? Graphic user interface stuff. And right now that'll just be a placeholder for my crosshairs graphic. And if I open this up, this should open up in Photoshop. By the way, if you're not already subscribed to my main channel, you are so missing out on awesome content. It's youtube.com/Grill18. I play video games. All right, so my crosshair graphic here is, you can do this in any program, it's mostly transparent. I used black pixels to make sort of a square, and then I used some white pixels as an outline over here. Oh my god, I just realized this entire time I forgot to make my font size bigger. Over here. I am recording at 1080p, am I not? Okay, I am, so hopefully people can at least like blow things up to read, but I really apologize for the fact that in the last 2 videos I forgot to make my font size bigger. Probably happened before. Photoshop, yes. So the reason you use the white and the black is because the black pixels will show up great if you're on a bright colored background, but if you're mousing over, if the center of your screen, if your crosshairs goes over a dark area, you know, an area of blackness with not much light, well, you're not going to see these black pixels, so use a few white pixels on the outside. This is not a beautiful crosshair by any means whatsoever, but it works just great. So, let's go back into Unity. Now, there's lots of ways to make the crosshair and the GUI. To start off with, we're just going to use the absolute basic, most simplest way of doing it, just to get it to work, and we can do fancy stuff later on. All I'm going to do is go into Game Object, Create Other. I'm going to create a GUI texture. Now, if you happen to have this asset selected when you create the GUI texture, it will automatically use your crosshair. But if you didn't have it selected, like I did here intentionally, it will use the default Unity watermark graphic, but that's okay. We can go and retune this over here. So where it says texture, we can just drag our texture into there. Now, again, if you had it selected when you create the GUI texture, it will automatically fill out all the correct sizes. In this case, it doesn't. It used the watermark ones. Well, I happen to know my crosshairs. If I go over here, I know that this graphic is, well, that's annoying. It's 16 by 16. Okay? You can also find that out, I'm pretty sure, in Unity over here. Yeah, if I click on this, it'll tell me it's 16 by 16. So that's good. So the width and height, 16 and 16. This pixel offset, if you just have it to 0 and 0, by default, it's setting, so right now, my transform, it's at position 0.5 and 0.5. The Z is just a stacking thing. You can ignore the Z. The X and Y here, if I go and bring this down, you can see the lower the number, the furthest to the left it goes. In fact, if I set this to 0, it'll be touching the leftmost side of the screen. As touching as it can be, given the fact that I actually have some space over here, but that's okay. It's touching the left-hand side of the screen. And if I set this, if I set this X position all the way to 1, it's actually going to disappear. You can see I'm at 0.98, and it's at the edge. And if I were to go all the way to 1, it would disappear. The reason is, let me set this back to 0.5 and 0.5. At 0.5 and 0.5, this thing is positioned directly in the middle of the screen, but it's actually the top left corner of this graphic that's actually in the middle of the screen. Okay, so if I go back into Photoshop, it's this point right here that's at the center of the screen. So the reason you put in the offset is to center it properly. So I'm going to go -8 and -8, and now my image is direct. Actually, I lied. It's this corner here that was in the middle of the screen. I forget that the Y coordinates are inverted with these graphics. So it's this corner here was being in the middle. By going -8 and -8, now right here is positioned at the middle of my screen, which is exactly where I'd want the crosshair to be. So now it should be considerably easier to shoot this box. Right? Line it up. Boom. Box goes away. Groovy. I'm going to rename this thing called Unity Watermark. I'm going to rename it to Crosshairs. And I'm going to create another empty game object that I'm going to center for convenience. And I'm going to go _ GUI stuff. And I'm just going to stick the crosshairs in there and then forget about it. All right, keep things nice and neat and organized. So I've got crates, and I could put crates all over the map. Wow, this video has gone on way too long. I did want to put in one little note. So this is still not working properly on the network. So in the next video, we will have to get the networking on this working properly. And why does it not work on the network? Well, I still have it in offline mode, but if I were to put it back into regular mode, oh, I'll show you what the hell. I really have to cut this short, but let's take off offline mode. Let's go and compile this game. All right, so we've got the Windows one here. Just make sure I connect and spawn. Come on, there we go. I'm going to move myself over to the other side of this cube. And because it's got a collider, we do bump into it, which is great. We can also jump onto it, which is awesome. Let me pull back over there and then spawn a copy of myself over on this side. Our characters cannot yet shoot each other, but that's all right. So over here in my Windows version, I'm going to shoot the box. And the box will disappear over here, but it will not disappear on the other side. Boop. See that? So we are not currently syncing this information over the network. So I can actually walk through where the box appears to be. Right over here. There we go. Now standing in the box on the other person's screen. But there's no synchronization whatsoever. So in the next one, we will target some tricky issues with this box that exist on more than one level. One is the health synchronization, but two is the way that you destroy objects. This box behaves a little bit differently than, say, if we were shooting one of the players. But that'll have to wait until next time. See you, folks. Bye-bye.